Hello, everybody. Can everybody hear me okay? Okay, Cheyenne, it looked like you were trying to talk. However, I didn't hear any sound coming from you. So I'm not sure if your mic is on or not. There is a button down in the bottom left-hand screen. It's a little orange sound button. You can click on that and it will allow you to be able to talk. So the mic needs to be on and enabled for that to happen. Okay.
Is that better?
Yes. That was perfect. Thank you. Okay, so today we're going to go through a couple different things. One of the first thing is to see how this software works, just kind of get familiar with that. And then the second piece will be to go through the structures and properties of water to have you a little bit more familiar with that. Acacia, I see that it says I'm breaking up, and I will try my best to make sure that the sound is available to you. It is, of course, over the internet, so that could happen. This is being recorded, so you can always go back and access the recording of this particular session a little bit later if you need to. Okay, so what you'll see is you'll see my face in that corner there, and that is the video. I can pass the video off to you if I choose to, if you guys at any point in time. I usually don't because mostly it's me, sharing information with you. But the video is over here in the top left corner of your screen. You'll also see if I have any videos to show you, this is where that information can be located as well. You'll see up in that quadrant is what we call it. There's a little up arrow. If you click on that up arrow, it will cause that small section of the screen to become larger, so that's all that you would see. So for each quadrant, you'll see a small up arrow in the right-hand corner, and that will enlarge that piece of the presentation to make it an entire screen. Next to my face is where any presentations or PowerPoints will be loaded. So this one in particular, we'll be talking about the properties of water. So we'll go through the PowerPoint slide. So again, this information in the PowerPoint will be recorded so you can access that information later if you need it. Down at the bottom is kind of more for you guys. It will also help kind of enhance this particular session. If you see down at the bottom left, there is a map. It's showing where we are all located, which is kind of fun if we're not all from the same area. But for now, what you'll see is there's 4 icons. The first one is the map. If you see the last icon, it looks like a little yellow notepad. If you want to click on that, it'll give you the option to add a note. So as you are taking or listening to material, you have a drop-down menu where you can create a group or a personal note, and you can add those notes as we go along. So you add save note or add note, type in what you need, and then hit save. So you should all be able to see, if you click on that yellow pad of paper, you should be able to see any notes that people post over here on the left-hand side. Okay. Then next to that is what we call a whiteboard. So the whiteboard should be available to you. It's in the bottom right-hand corner. You'll see different icons, letters, text boxes, pencils, things like that, where you can actually write on the whiteboard. So right now this is open for you guys to use if you would like to. It kind of gives you an opportunity. There we go. Gives you an opportunity to draw, maybe collaborate if we need to. This particular presentation, we won't have a lot of collaboration, but it's there for us to use if we need to. Down at the bottom, what you'll see is some smiley faces. This is kind of a check-in if you are having trouble understanding anything, or you are, yeah, I get this. It has different face emoticons that you can press, and those will show up next to your name on my list of attendees to let me know how you guys are doing. There's also a hand down there, and that kind of is like a raised hand where I can either, it signals that you have a question or would like to say something. You can do it a couple different ways. Raise your hand and I can pass the mic over to you so that you can chat, or you can add any questions in the text chat box on the very right hand side, and I will try to get to your question as soon as I can. So that's just kind of a rundown. That's a quick and dirty about how this particular system works. We will be utilizing some of these options a little more later, but today is kind of more of a introductory to the system and a quick rundown on the structure and properties of water. So currently, does anybody, if you have a question, please either type it in the chat, in the text chat, or press the hand button before I move on to actually talk about the topic at hand. Okay, so I'm going to move on. Whoops. Okay, I'm going to move on and start talking about the properties of water. If you have questions, please feel free to, again, raise your hand or type them in the text chat as we go along. So this is, you can, if you'd like, increase the PowerPoint so it becomes a full screen if you need to. Here are several different properties of water that we'll talk about. The structure, that water is a polar molecule, capillary action, the fact that it's a universal solvent and what that means, cohesion and adhesion, surface tension, density, and specific heat, and then we'll just touch on buoyancy, which kind of has a lot to do with density of an object and of water. Okay, so the first one is the structure. So water is made up of a molecule. One molecule of water has two hydrogen atoms that's bonded with an oxygen atom. And we won't go into it too much, but they're covalently bonded together, which means that they're sharing their electrons. And so for each oxygen molecule, there is two hydrogen molecules that are attached. So this bond forms a covalent bond, and you can see that by, here I have oxygen. Oxygen has 6 electrons in its outer shell. It likes to have 8. So luckily hydrogen, each hydrogen atom has 1 electron. So they'll make a bond or share a bond between these 2 electrons from hydrogen and 1 from oxygen, creating a covalent bond. Writing the chemical formula, you write the H2O. You can see it's got a subscript here for indicating there's 2 hydrogen atoms that are attached to 1 oxygen atom. Okay, so this is 1 molecule of water. So here, water molecules will then bind to each other, creating a whole lot of water molecules. So when you see a drop of water, millions of molecules of water will make up 1 raindrop. So we don't see or cannot see the water on a molecular level because it is very, very small. Okay. Molecules that have an electrical charge area are called polar molecules, a lot like a battery. Or we have, just like the Earth, we have a North Pole and we have a South Pole. And the reason we call those poles is because we actually have a magnetic field that surrounds our Earth. So when you have a positive side that's charged and a negative side that's charged, we call that polar because it has two poles. We also talk that way or use that term when we're discussing molecules. Molecules do have some electrically charged areas. So when it does, we call that a polar molecule, just like in a battery. Now, nonpolar substances are molecules that will not have a charged end, so they are neutral all the way around. Water happens to be a polar molecule because it has a positive end over here on the hydrogen side and a negative end on the oxygen side. So it's slightly positive. So there is some attraction from negative particles on the positive end. And it's slightly negative over here on the oxygen end. So you have an attraction to positive molecules from the oxygen side. The positive hydrogen end will attract to the negative end of the oxygen, creating what we call a hydrogen bond because it is being attracted by those positive and negative ends between the two molecules. Now, because water is a polar substance, it has several different properties that we'll talk about, which is cohesion, adhesion, specific heat, the fact that it's a universal solvent. We'll look at capillary action and surface tension. Okay, so for capillary action is the first one, and that is where molecules will actually cling to each other and cling to the sides of whatever substance it happens to be in, and it will travel against gravity. So, for instance, I'm going to try this, and I'm not sure if it will work, but I'm going to share my desktop and show you a PowerPoint, the same PowerPoint, but the problem with the system is that it doesn't show any graphics. It just shows the picture of the PowerPoint. So I want to show you some animation. So let's try this and see if it works. Okay, there we go. So capillary action, as you can see, it will cause the green. We start out with yellow. These are my yellow molecules inside the tube. And over time, the green molecules, or the green water that's sitting in the bottom of the Petri dish, will start to change color and move up and combine with the yellow molecules. Oh, okay. So maybe it didn't work. Thanks for letting me know. So I was trying to share my desktop so that you could see what I see on my desktop, but that didn't work, so I apologize. But what was showing is this picture of the PowerPoint, and the green water at the bottom would actually mix with the yellow and would start to move up against gravity up the straw. It's very similar to when plants get their nutrients and water from the soil. That capillary action is what moves those nutrients up through the roots into the leaves of the plants. So that is one property of water. It's called capillary action, and that's the movement of water against gravity up through a tube because of its adhesion and cohesion properties. Let's bring us, okay, I froze. So Rachel, which part did you get? The part about capillary action, or does that make sense to you? Or do you want me to go through it again? No? Okay. So I'll just repeat. Okay. Okay, we're working out some technical difficulties. Hopefully it will come back. Okay, so you were froze for about 4 minutes, Rachel says. Okay, so we were discussing capillary action. I hope, Rachel, that you're back in and can hear me okay now. What we were discussing is capillary action is the movement of water or the movement of a liquid against gravity. So it's taking that water from the bottom and moving up through a tube against the movement of gravity. So it's moving in the opposite direction. So what you would have saw if it was working properly is the green would actually mix with that yellow, and that green liquid would move up towards the top of the tube. So that's what capillary action means. So it's using cohesion and adhesion to move against gravity, using the surrounding material to cause the water molecules to move. Okay. So surface tension. Have you guys ever tried to skip rocks on the river? And when you do that, this is because of what we call surface tension. It's the same reason why if you had those bug skippers that skip across the water that appear to be walking on water. Oh, okay. Okay, Rachel, make sure that when we do use Jigsaw that you are in Firefox and not using Internet Explorer or Chrome, because that does happen. It will cause it to freeze. It also has to do with your wireless connection through your computer. So sometimes when that wireless connection will get interrupted, it causes the screen to freeze. So if that happens to you, try logging out and coming back in, or refreshing your page, and that might work as well. And then keep in mind that these are recorded or should be recorded. So after the meeting, we will upload this so you'll be able to review anything that you happen to miss if it was frozen. So I'm going to go ahead and type that out here in the notes just because there are some people that has had this frozen. So I'm going to add this to the notes really quick and stop talking for a second. So I'll give you guys a break for just a quick minute. Okay, so I'm going to go ahead and continue. So we were talking about surface tension. So what happens here in surface tension is the water molecules will form bonds to create a strong connection across the top of the surface, or the top of the water surface. And what happens is that it takes a little bit more energy to break that bond or break that connection. So surface tension allows for things to kind of sit on top of the water because it's a strong enough bond to prevent anything from penetrating that bond or that structure. So it's the reason why you can take rocks and skip them across the lake, is because it needs a little more energy to be able to break that seal or to break that surface of the water. Okay, it's kind of acts like a solid. Now it is just liquid, it is water, and it is, in the sense, it is a strong bond, but it's not strong enough that we are able to, of course, break that surface. So I'll give you another example of that in just a minute. So universal solvent. We call it a universal solvent is because most substances are polar, it will actually mix with other substances. Because of its polarity, we are able to use it as a solvent and use it to make solutions. Solvent is a part of a solution. It's the main part of a solution, and you use it to dilute things. So for instance, putting sugar in your tea. Okay, we are dissolving the sugar, and because sugar can be dissolved in water. Same thing with other chemicals, especially in the laboratory. We use water to dilute a lot of substances because of its polarity. Now, again, remember, solvent is what's being dissolved, or using it as a dissolvent. Solute is what you're going to be dissolving in that water. So other polar molecules can be dissolved by water. If it's nonpolar, that means that it can't be dissolved, such as alcohol, or actually, I'm sorry, oil and vinegar. That's a good example. Okay, vinegar is polar, oil is nonpolar. So the two of those substances will not mix, and that has to do again with that positive and negative charge of the overall molecule. So water is what we call the universal solvent, not only because it's polar, there are a lot of substances that are polar, but it has sort of a wedge-like shape. So it has oxygen at the corner, and then it has two prongs coming out that look like, that are the hydrogen molecules. So it creates sort of a wedge. And this wedge shape will get into the middle of other molecules and break up substances into smaller pieces. And that's what's happening when something's being dissolved, is that it's breaking up into smaller pieces and being incorporated into the solvent, which in this case we're talking about water. Okay, cohesion. Cohesion is because a water is polar, so it becomes attracted to itself. Okay. Cohesive, it's kind of like I use the term, you're in a cohesive group, and cohesive group means that you are attracted to itself or attracted to each other. So cohesion is the attractive force between water molecules, so between itself is what we call cohesion. Just like, because they like to stick together, water molecules have a very strong cohesive tendency, whereas rubbing alcohol does, but not nearly as much as water. And that's why you've done in the past maybe a lab where you're trying to get as much water on the top of a penny, or sometimes you overfill your glass too much and you end up with the water sort of sticking out on top of the cup. This is because of the cohesion. Because water is attracted to each other, it will actually bubble up over a substance. Adhesion. Adhesion is similar, but it's water being attracted to other polar substances. So think of like adhesive tape. Adhesive tape is the clear plastic Scotch tape that you would use to stick two separate things together. So that's when I think of adhesion, I think of adhesive tape. Because it's polar, it's attracted to other polar substances. So adhesion is the attraction between water and something else, whereas cohesion is the attraction between water and water, or between water and itself. Oh, Savannah. Oh, goodness. Okay. So just like when it rains, you'll see water droplets appear on your windshield. Okay, adhesion is the reason why those water droplets are actually attached to your windshield and don't always roll off. Eventually you get too much water and that energy or mass of that water will cause it then to roll off your windshield. So again, when you're measuring, we look at, in a cylinder, we look at the meniscus of a cylinder to find the actual true measurement. Okay, it creates this meniscus, or this little upside down bubble, because of the adhesion properties. So the water kind of clings to the side of that particular tube instead of making a nice flat surface, because it's attracted to its surroundings. Okay. So again, cohesion, water molecules like to stick to each other, and adhesion, water molecules like to stick to other things. Specific heat is another property of water. It is the amount of energy needed to increase the temperature of something by 1 degree. Okay, water has a very high specific heat, which means it takes a lot of energy to increase water by 1 degree. You see this a lot on the Oregon coast. We have, even when it's 80 degrees outside, you get into the ocean and it's freezing still. Okay, it takes a very long time for that water to get heated, okay, because of that attraction between water molecules. It is what makes our climate and our earth habitable, because the water, there's so much water that it kind of buffers that change in temperature. So especially around ocean and water bodies, the temperature is very mild versus inland or in the desert, because it does take a lot of energy to raise and lower the temperature of the water. Okay, so for instance, just to give you an idea, like cloth has a specific heat of 1340, metal has a specific heat of 500. They do get very hot just in your car with your seatbelt. However, water takes a lot more for you to change the temperature, because it has a very high specific heat. It takes quite a bit of energy to raise the temperature of water. So that's another property. So unfortunately, like I said, we're dealing with technology. So I know some of you are frustrated with it freezing up. And unfortunately, this is a new system for me as well. So I'm not as familiar with why that's happening on your end. We can do a couple different things. It is being recorded, so I will put that up. It'll take me a couple hours, but it'll be up there so you can go back and listen to it if you need to. The main important piece is that there is a properties of water assignment that if you have not done already, you will still need to do. And the assignment is taking a lab and creating a properties of water lab. That's, I believe it's assignment 1.04. So for attending the lecture, you will get credit for attending the lecture, but you will also, for those of you that did not attend the lecture, will still have to do an additional assignment. And as you can see down at the bottom, there's an attachment called the Properties of Water Lab. So for students who did not attend the lecture, they are going to be responsible for completing this second lab, Properties of Water. So because you guys are here, you will be excused from that. Okay. So does anybody have any questions on